All right, guys. So to start, we're gonna start with fluid flow, fluent. I'm gonna drag it up here. Click geometry. I'm gonna click edit. Wait for it to run. Select a plane, any plane, and start a sketch for our CD nozzle. This is the inlet to the outlet right here. Make some kind of straight. It's good enough for me. Okay, so connect them in the middle here. We'll fix all of that later. Just connect all the lines together. All right, there we go. We go to constraints. We want midpoint constraints. Put here and here. This one and this one. Okay. Okay, so now we're gonna dimension them. This I used as 25. So, 5. What's 35? Try putting the horizontal distance, see what happens. And then horizontal 25. Okay. 25. This one was 5. This 10. Right, so we're basically in the middle. Thing. It's like there's need to midpoint here. What I do is just draw a line here, create another midpoint constraint, this line and this, and that should be center off, perfectly symmetrical. All right. Then we want to trim off the excess from the internal lines. Okay, so our sketch is done. Go back to modeling. We want to add a surface. So we select all the surfaces. Okay, and then we generate after we select all the walls. And we are done with the geometry side to close it off. Now we're gonna go to mesh to edit this. So we got a new design, we gotta mesh it all out. Okay, gonna click mesh, I will put 1.1 meters, I think that's a good amount. Right here, knows the body surfaces. Let's try naming it first. So I'm gonna click there and click name, I'll put inlet, and I'll click on the outlet, right click, outlet, and we'll select the walls. Make sure you're holding control button so you can select all the walls. Walls. Everything should be correctly labeled now. There. So on the mesh part. I added a triangle method, so just click methods and you could add the triangle methods on the mesh part. Then all you gotta do is change the size, and then you generate. Forgot to add the triangles to where it's at. Now it works now. Now we wait for it to mesh. Is it done? See all the triangles here? Pretty good mesh, pretty small. Okay, we're done with the mesh size. You want to right click and update mesh so the setup can receive it. Okay, so now we're gonna edit setup using 4 cores, double precision. Start it up. Okay, so you got here, velocity inlet, pressure outlet. Okay, click check, see checking mesh, everything's okay. I'm gonna use density based because we want a supersonic. Everything else is the same. Great. Here, fluid, make sure it's air. Energy, make sure energy is on, and we're using viscous K omega SST. Okay, so we're at the inlet. Make sure it's going to be a pressure inlet. Put the amount of pressure that you calculated from your area ratio inlet to outlet. Any temperature, I guess. Good, and you click apply after you put in the pressure. Same thing as the outlet. What's your outlet pressure? This is what's going to generate the normal shock or supersonic flow. So make sure you can change this for higher pressures. Normal shocks are created, lower pressures on the outlet. Supersonic flow is created, no normal shock. So apply. Okay, it's done. But initialization, hybrid initialization, done. I'm gonna run some calculations now. I put 150 iterations, so let's calculate that. Wait. Okay, so first of all, let's start getting the contours. Then double click contours. And if we want the pressure contour, it's already here as default. So you want to select the interior. That's where we're getting the pressure contour at. Click save and display. Oops, I was zoomed in, sorry. And here you are. This is the pressure contour. We have the density contour, save and display. Same thing. Velocity right here. And this one is working for the normal shock since I put 200,000 pascals on the outlet. So you see that the velocity is basically almost the same as the um, inlet velocity. So, and that makes sense because there's a normal shock going on. And Mach number is also under the velocity tab right here. And speed of sound is going to be under properties. They're going to find speed of sound right here. And you also display that. Right, so you could get all those contours and post them on the assignment. Now, we want to draw a center line and get the change in plots of also speed of sound, temperature, also the temperature contour right here. Sorry about that. This one also here. Okay. But we want to get speed of sound, temperature, velocity, Mach number. So we want to get a plot, right? So we're gonna go to XY plot. Gonna go new surface, line rake. Where is this? I don't know. So I'm gonna guesstimate. So select the points right here. I'm gonna select, this is my inlet, boom. And the other point, a little bit in the middle, boom. There we go. Here are my coordinates. So what I can do is I could change the Y and put 0 for both, and it'll be perfectly in the center. There you go. And then I create it, and I close. So that created line 8 right here. So same thing, pressure selected, save and plot for line 8. It'll give you the change in plot for the center line of this CD nozzle. Change in density, change in plot density of the center line of CD nozzle. Velocity magnitude, change in velocity. Under the same velocity tab, you could find the Mach number as well. Should be the same. Properties, you could find the speed of sound. Change in speed of sound, there you go. And temperature right here. Right? That should be all. That should be how you find all the change in plots and the contours as well. And ANSYS, how you set it up, and it's pretty simple sketch. My name is Renato Giordani, and this is my project. So yeah, thank you.